Online Acoustics and to our channel. I'm going to share a spreadsheet that we use for calculation of the reverberation time in different kinds of rooms, and you can download this in our website. I'm going to drop the link at the description. So first, what we need to insert in the spreadsheet is the dimensions of the room. You can use this spreadsheet for small rooms, like a practice room, up to a concert hall or church. So it is valid for different types of rooms. It doesn't matter. So I'm going to, let's say that I'm doing like a small theater, for instance, or a small concert hall, for instance, 30 meters, 20 meters, and maybe 7 meters. Let me just rectify. Maybe 15 over here, 20, 15, 25. Okay. This spreadsheet, it uses the metric system, so I didn't have time to change the units for the imperial system. So if you're from the UK or the US, you need to adopt the spreadsheet. So I'm studying a space with around let me see, with a surface area of 350 square meters. So the spreadsheet automatically calculates the surfaces, the area of the surfaces of the room. So you have the side wall, the front wall, the rear wall, etc., etc. Calculates the floor ceiling. Sorry, I was wrong. 375 square meters and the volume of the room. Okay. And now we need to input the optimal reverberation time of the room. So this is, let's say that this is like a small theater. So I'm going to do something like 1.2 seconds. So I can use the space for speech and music. You can also change the frequency of the optimal reverberation time, changing these volumes over here. So usually there's a longer reverberation time in this kind of rooms. So at 125 Hertz, we increase the reverberation time by 1.5, and then we are decreasing the reverberation time at higher frequencies because, of course, this is a large space, and the air enclosed inside the room, it will absorb the sound as well. So here we can see our optimal reverberation time. So this value over here is for 500 Hertz, which is usually the main frequency, and then we see kind of like a roll-off up until 4K, and there's an increase in the mid and the lower mid frequencies. So this is perfectly acceptable. Now, going below, I have the absorption of the air, sound absorption due to the air, and we can change the humidity of the room, and it will increase the absorption of the room, having in consideration the humidity. So for instance, let's say, I think let's say like 40% humidity, and we have these values over here are the absorption done by the air inside the room. As you can see, the absorption increases as function of the frequency. So higher higher octave bands will have higher frequency absorption due to humidity. Okay, and now we come up to the acoustical treatment of the room. So keep in mind that this is a very simple spreadsheet. So this is like I use this for when I want to have an idea about the quantity of material, the material that I want to use in the room. So it has different assumptions. For instance, it assumes that all the surfaces are highly reflective, except the acoustical treatment that we are implementing in each of the surfaces of the room. So that's one of the first considerations. Um, of course, it doesn't study diffuser, so I cannot use this model or this spreadsheet to accurately predict the reverberation time in a room if I'm using diffusers or for very complex geometry. So this is just a very fast and easy way just to get a glance of the picture of the overall picture of the room. So we can change the acoustical treatment for each of the surfaces of the room, like the ceiling. Then we have the floor, we have the side walls, the rear walls and the front walls. They will have the same amount of treatment, and we have the floor as well. So, and how do I operate this spreadsheet? It's very simple. So I go here, type of panel. I choose my type of panel. There's already pre-established materials that you can of course you can change the absorption characteristics in another tab. I'm going to show you later on, but there's also already a bunch of predefined materials that I have included on the spreadsheet. So you have like broadband absorption with fabric. You have wood panels. There's thinner foam. There's for the floor. There's MDF floor. There's floor with the carpet. Okay, so I'm just going to use wood panel over here. And then here I can define the percentage of the surface area of my ceiling that is covered with acoustical treatment. So I can say, for instance, it's 90%, or I can say it's 20%, for instance. I can also change from percentage to square meters. Okay, so for instance, the area of my ceiling is 375 square meters, and I can define 50 meters of acoustical panels on the ceiling. I usually prefer to be honest, I usually prefer to use the percentage area. It's much easier and much faster to get results. So I'm done with the ceiling. Now I can go to my floor. So I'm going to keep the floor with the rigid material. So MDF floor, totally cut. So the percentage will be 100%. It's okay. And then I have the side walls. The side walls I'm going to change. For instance, I'm going to use a broadband material, like for instance foam covered with fabric, and let's say that I want 50% of the percentage of the side walls. This keeping the attention that this is the two side walls, so I cannot define different characteristics for independently for each side wall. That's why this model is very simple. It's very basic. And also for the front and the rear wall, I'm going to add like 40% of not wood panel. So I'm going to choose the same material. Okay. Okay, and now here I get the results of the frequency of my prediction using different prediction formulas. So we have Sabin with absorption, with air absorption included. We have Iron Norris, which is a formula that we use more for smaller rooms. We have Fitzroy, which is another formula that is used for large rooms that has specific considerations, and there's also Arau-Pachat's, which is another prediction formula for this kind of rooms. And then we have our optimal room reverberation time. Sorry, I'm a bit tired, so that's why I'm kind of speaking slow. Here on this tab over here, we can see our optimal curve of reverberation time at our orange, and we have the different reverberation time predictions for the different scenarios. Of course, this will change dependently on how we distribute absorption inside the room. For instance, if I only place absorption on the ceiling, for instance, this is going to give me a very different picture. So let's say that, okay, so I have 50% of absorption on the ceiling, but then I'm on the floor, it's MDF. Now I'm going to change the material, and I'm going to say that's MDF again. And so I'm reducing the absorption of the room, and the only material that I have absorption is on the ceiling. So now the prediction is very different. As you can see, of course, since I have reduced the absorption of the room, the reverberation time has increased a lot, and it's now much higher than is expected. But now what I can see is that these formulas actually give very different values. For instance, Fitzroy gives me a very gives me a much higher value compared to the other formulas. And probably in this case, this is the curve that is going to be used for this sort of prediction, when I'm just going to place absorption on the ceiling and not on the other areas, on the other surfaces of the room. So since the absorption is not placed in a distributed or in a evenly quantity on the different sides of the room, this kind of some of these formulas actually will underestimate the reverberation time in the room. So when I'm finished with the room, I'm going to measure the reverberation time will probably closer to this line over here, the purple line, than the green or the blue line. Okay, so it's very important for us to understand that these are only prediction tools, and we need to understand how sound operates for each scenario. Okay. So now I'm going back to my room. I'm going back to the side walls and change it again to the initial prediction, and then we have something which is closer to the optimal reverberation time. And the last tab is the material. So here you can change all the characteristics of the panel. So if you want to change this, you can change. Like I can go to a certain third octave band. Keep in mind that this is classified using third octave bands and not only typical octave bands. So we have 100, 125, 160, 200, 250, etc., etc. So I can change these values if I want. So for instance, this value is not 0.09, it's 0.9. So of course I can change these materials, and I can change all the information that I have here so I can have a better representation of the materials that I want to use in my room. And this is, and so basically this is our spreadsheet. It's very easy to use. Keep in mind that it's very easy to use, but you also need uh, to realize the restrictions that the spreadsheet has. And I'm going to drop the link below. And if you like the video and if you like the channel, please don't forget to subscribe. Thank you so much, and stay tuned for further uploads, probably during this week. Thank you so much.